Unlock the secrets of Moroccan baccalaureate math, numerical sequences, and convergence. Master your exams with this essential guide. What are numerical sequences? Dive into the foundational concepts that build the bridge to convergence. Get ready for clarity. Convergence, the big idea. When does a sequence settle down? We'll demystify limits and infinite behavior visually. Proven techniques for Moroccan baccalaureate success. Learn how to analyze, prove, and solve sequence and convergence problems with confidence. Let's dive into the recursive definition of sequences, where each term depends on the previous one. Essential for understanding complex series and their patterns. Understanding explicit formulas is key. This direct approach calculates any term without needing prior values, simplifying complex series analysis. Monotonicity, sequences that either always increase or always decrease. This fundamental property is crucial when we analyze their convergence towards a convergence, when a sequence approaches a specific value as n goes to infinity. We'll explore tests and theorems to determine these limiting values. Did you know that some infinite sequences, despite going on forever, actually approach a single specific number? This is convergence. Not all infinite sequences behave. Some oscillate wildly or grow infinitely large, never settling on a single value. These are divergent sequences. The epsilon-delta definition is the rigorous math proof for convergence. It says for any tiny error epsilon, there's a point delta, beyond which the sequence. Understanding convergence is key. It unlocks concepts like infinite series, calculus limits, and even the behavior of algorithms in computer science. Scene 13. From simple beginnings, sequences grow. We'll explore arithmetic and geometric sequences, the building blocks of calculus. Think of them. Scene 14. Convergence is key. When a sequence marches towards a single finite value, it converges. We'll visualize this limit graphically. Scene 15. Divergence means no limit. Sequences that grow infinitely or oscillate wildly don't settle. We'll see examples of sequences. Scene 16. Real-world sequences matter. From population growth to decay, financial models to physics, understanding limits helps us predict an geometric progression. Each term is found by multiplying the previous one by a fixed, non-zero number called the common ratio. Notice the exponential growth. Convergence. A sequence converges if its terms approach a single fixed value as n tends to infinity. This limit is the sequence's value. Divergence. Sequences that don't converge either tend towards infinity or oscillate without approaching a specific limit value. They simply don't settle. Monotonicity and boundedness. A sequence is monotonic if it's always increasing or always decreasing. If it has both an upper and lower bound, it must converge. Let's dive into numerical sequences, the building blocks of calculus. We'll explore how they unfold, one term at a time, laying the groundwork for convergence. Understanding the limit is key. We'll explore different types of limits and how they dictate the ultimate destination of our sequences. Convergence, when a sequence zeroes in on a single value. We'll master tests to prove if a sequence converges or diverges. Mastering convergence unlocks advanced topics. We'll tackle monotonic sequences and the monotone convergence theorem for deeper insights. Understanding the future of sequential data analysis is key. These mathematical sequences unlock deeper insights into complex patterns. Predictive modeling relies on understanding convergence. These algorithms forecast trends with increasing accuracy, shaping our technological future. The evolution of AI is directly linked to convergence principles. Advanced learning models will emerge, impacting every facet of our digital lives. Mastering sequences prepares you for advanced computational approaches. Embrace these concepts to innovate and lead in the technology of tomorrow. In Morocco, baccalaureate math focuses on sequences and convergence, essential for future studies. Understanding convergence is key. We'll explore limits of sequences, understanding their behavior as n approaches infinity. We'll analyze different types of sequences, arithmetic, geometric, and others, to determine their convergence properties. Mastering convergence opens doors to advanced calculus and problem-solving skills required for your Moroccan baccalaureate. Myth busted. Limits always exist for every sequence. Not true. Some sequences diverge to infinity or oscillate endlessly. Myth. The order of terms doesn't matter for convergence. Wrong. For monotonic sequences, the order is crucial for a predictable limit. Myth. All convergent sequences approach zero. False. A sequence can converge to any real number, not just zero. Myth. The Bolzano-Weierstrass theorem applies to all sequences. No, it's specific. It guarantees a convergent subsequence from bounded sequences. Let's dive into arithmetic and geometric sequences, understanding their core formulas for term calculation and sums. Explore the concept of convergence, when a sequence approaches a specific limit as n tends to infinity. Understand the monotone convergence theorem. A bounded monotonic sequence is guaranteed to converge. Divergence occurs when a sequence does not approach a single limit, often growing infinitely large or oscillating. Did you know? The convergence of a sequence isn't always obvious. Sometimes you need to look beyond the first few terms to see the whole picture. Contrary to intuition, a sequence can oscillate indefinitely yet still converge. It depends on the amplitude of its oscillations, shrinking towards zero. A sequence might appear random, but if its terms are bounded and monotonic, convergence is guaranteed. It's a powerful theorem. The limit of a sequence doesn't have to be a number it actually reaches. It's the value the sequence approaches infinitely closely. Scene 45. Real-world application of arithmetic sequences. Imagine saving $100 each week. By week 52, how much will you have? Scene 46. Geometric sequences in action. Think compound interest. Investing $1,000 at 5% annual growth. Scene 47. Convergence in everyday life. Consider a bouncing ball. Each bounce is lower than the last. Does it ever stop bouncing? Scene 48. Using sequences to model population growth. A city's population grows by 10% yearly. Starting with 100,000, understanding convergence is key. A sequence converges if its terms approach a single, finite value, as n goes to infinity. Divergence occurs when a sequence's terms grow infinitely large, infinitely small, or oscillate without settling. The monotone convergence theorem is powerful. If a sequence is both monotonic, always increasing or decreasing, and bounded, it must converge. Subsequences offer crucial insights. If a sequence has a convergent subsequence, it doesn't guarantee the whole sequence converges, but it's a strong hint. Let's dive into the foundational concepts of numerical sequences, the building blocks of calculus and analysis in Morocco's baccalaureate math curriculum. Understanding convergence is key. We'll explore how sequences approach a specific limit, a fundamental concept for advanced mathematical studies. We'll analyze different types of sequences, like arithmetic and geometric, and learn techniques to determine their convergence or divergence. Mastering these concepts equips you for complex problems. Let's solidify your understanding with practical examples and exam-style questions. Summary. Sequences are ordered lists of numbers. Convergence means the sequence approaches a single value as n goes to infinity. We can determine convergence using limits. If the limit of a n as n approaches infinity exists and is finite, the sequence converges. Divergence happens when a sequence doesn't approach a single finite value. It might go to infinity or oscillate. Mastering sequences and convergence is crucial for understanding calculus. Keep practicing, and you'll ace your Moroccan baccalaureate math exams.